Hello, my name is Jinho Kim, and I'm an instructor at the Elite Institute Academy. Today, we'll be going over some problems that frequently appear in SSAT upper level mathematics. So let's get started. If the points 4, 2 and negative 1k are on a line that is perpendicular to the line y equals 2x plus 1, what is the value of k? So to solve this problem, what are we given? We're given the line that crosses the 2 points 4, 2 and negative 1k. And what do we know about it? It's perpendicular to the line y equals 2x plus 1. So let's start with this one. So given the slope containing the points 4, 2 and negative 1k, what's the slope? How do I find the slope? I find the slope by, what do we know about it? Rise over run, and we calculate the rise by what? Taking the differences in y, which is k minus 2, and taking the differences in x, which is going to be my run, minus 1, minus 4. Therefore, slope of the line that contains the points 4, 2, and negative 1k is going to be k minus 2 over negative 5. Okay? And of course, that line has to be perpendicular to the line 2x plus 1. And what is that? What is the slope of this line? It is simply the coefficient of x, which is 2. So we know has to be the slope of this 2x plus 1 has to be 2. So what do we know about the slopes of the two perpendicular lines? So what do we know about it? We know they have to do what? They have to multiply to become negative 1. Therefore, we know k minus 2 over negative 5 times 2 has to be equal to negative 1. So what does that make my k? Now, this is a simple algebra. We know that what? It's going to be k minus 2, and then we multiply negative 5 on both sides, which makes it k minus 2 times 2 is equal to negative 5 times negative 1, which is going to be 5. And then what do? We divide both sides by 2 to get k minus 2 is equal to 5 over 2. Then we finally add 2 to both sides to make k equals 5 over 2 plus 2, which is equal to 9 over 2. Therefore, the answer is C. All right, on to the next problem. A circle, a square, and an equilateral triangle all have the same perimeter. Which of the following lists the shape in increasing order of area? So with this problem, let's take a look at this. They all have the same perimeter. Do we have any restriction on what the perimeter has to be? No. So therefore, what do? We're going to simply set the perimeter to be 1. So let's start drawing it. I have the circle, whoops, a bit better circle, and square, and then also equilateral triangle. And let's just assume that they all have the same perimeter of 1. Okay? So let's think about it. What does that make my radius? That's going to be 1 over 2 pi. What does that make my side of square? That's going to be 1 over 4. And what does that make my equilateral triangle side? It's going to be 1 over 3. So now that we know what the radius and length of each side is with the square and equilateral triangle respectively, we can actually try to find out the area. So how do we figure out the area of the circle? What do? We take the radius, we square it, and then times by pi, which is going to be equal to 1 over 4 pi. And then for the square, it's going to be what? Area is going to be what? Two sides we gets multiplied to make it 1 over 4 squared, which is going to be equal to 1 over 16. Last but not least, what's going to happen with equilateral triangle? Well, equilateral triangle, what can we figure out? We know what? We can find out the height by dividing the side by half and then multiplying that by square root of 3. So that's going to be square root of 3 over 6. Therefore, area is square root of 3 over 6 times 1/3 and then times 1/2. That's going to be square root of 3 over 36. So now we have 3 different values, and all we really need to do is punch them into the calculator and see what we get. 1 over 4 pi, 1 over 16, and square root of 3 over 36. And it turns out that area of the circle is greater than the area of the square, which is greater than area of the equilateral triangle. Therefore, in the increasing order of the area is triangle, square, and circle. So rest boils down to simply a calculator work, and you will see this happen. All right? Wonderful. All right. The next problem. The average height of the boys is 5.2 feet, and the average height of the 4 girls is 4.9 feet. What is the average height in feet of all 6 children? So let's take a look at this. The average height of the 2 boys is 5.2 feet, which means what? If I let the heights of 2 boys be x and y respectively, then what does that mean? That means my average for those two is going to be equal to what? Sum of those two values divided by number of the data value, which is going to be 2, is equal to 5.2. So that means what? Sum of the two heights of the boys is going to be 2 times 5.2, which is equal to 10.4. Now, let's take a look at it, the next part. The average height of the 4 girls is 4.9 feet. That means what? If I let the heights of the girls be A, B, C, D, then the average is going to be what? Sum of those A, B, C, D, and then divided by 4, which is going to be equal to 4.9. So therefore, sum of those 4 values is going to be A plus B plus C plus D. And again, we multiply what? 4 times 4.9, which is going to be 19.6. So finally, they asked the question, what is the average height in feet of all 6 children? So in order to get the average height of all 6 children, what do I need to do? I need to take this x, y, a, b, c, d, and I need to add them all up. And then what do I need to do? I need to divide it by number of the data value, which is same thing as number of all children, which is 6. So that becomes my new average for all children. So how do I figure out the total heights? What do? I already know the total heights for boys and I know the total heights for girls. So all I need to do is add them up. Then finally divide it by 6. So therefore it's going to be what? 30 over 6, which is going to be equal to 5. And that is my average. Hence the answer is D. On to the next problem. So next problem involves exponential expressions. So what do we know about exponential expressions? What do we know about the powers? We know a to the power of negative b is same thing as taking 1 over a to the power of b. Vice versa, a to the power of b can be normally represented as 1a to the power of 1 over a to the power of negative b. So let's see if we can simplify this. So what do we know about it? We're going to start by converting all the negative powers into positive powers. So let's start by this one. 2 to the power of negative 2. So what happens? We know what? Because this is in the denominator, we're going to switch that over to the numerator. So it's going to become what? 2 to the power of 2 times 4. All right. Then x to the power of negative 3. Well, since we already, by taking this rule, what do we say? We can take this down to the denominator and have the power become positive. Then, of course, y to the power of 4 remains here. Then z also remains here. Then what happens to w to the power of negative 2? What do we know? Because this is in the denominator, we can shift it upwards to the numerator with power becoming positive by these rules. Therefore, now let's see if we can cancel something. All right, 2 squared times 4 is going to be what? 16. And then what do we have? We have x cubed. And then we have z, w squared times z, and then y to the 4th. So which one satisfies that expression? A, B, C, or D? The answer is D. On to the next question. So yes, this is the kind of question that tends to pop up rather frequently in SSAT upper level. The shaded region in the figure shown is divided by lines K, L, M, and S. The area between K and M is 45 square meters. Between L and 5 is 40 square meters. And between M and S is 25 square meters. What is the area in square meters between K and L? Okay, so let's think about it. So I'm going to designate the area in each of these segments as notations. And I call this A, and I call this B, I'm going to call this C, and I call this D, and I'm going to call this E. There's nothing wrong with this. So let's talk about this, the area between K and N. So let's start by talking about this and this. So what does that include? B and C. Therefore, what can we say about it? I can write this as B plus C is equal to 45. The area between L and S is 40 square meters. So that's going to be what? C and D. So that's going to be C plus D is 40 square meters. Then between M and S is 25 square meters. And what do we know about it? That means D is simply just equal to 25 square meters. So now that we know about all that, what is the area in square meters between K and L? So what does that tell me? K between the K and L is going to be what? Simply B. So we want to find what B is. So let's start by plugging in. Since D is equal to 25, and what other expression involves D? C plus D is equal to 40, which is saying that area between L and S is 40 square meters. So therefore, what does that make my C? That makes my C equal to 15, since 15 plus 25 is equal to 40. Then, which expression involves C? B plus C is equal to 45. Voila. So what does that mean? That means since C is equal to 30, since when C is equal to 15, that means B plus 15 is equal to 45, which makes B is equal to 30. Therefore, my answer is the area in square meters between K and L is equal to 30. All right, on to the last problem. If A plus B is divisible by 11, which of the following is also divisible by 11? So let's take a look at this. What does it mean by A plus B is divisible by 11? So what does that mean? That means if I take the integer multiple of A plus B, so if I multiply A plus B by any integer, which is like 1, 2, 3, 4, 5, 6, right? Then that also must be divisible by 11. So all we really need to do is take which of these answer choices make it necessary that it is an integer multiple of A plus B. So let's start by taking a look at it. A times B plus 11. Does it have anything to do with A plus B? No, because we need something that's like a plus B times some kind of constant, where constant is C is an integer, right? Because that's how we express an integer multiple of A plus B. Is A times B plus 11 sure, it could be for some specific value of A and B, but no, not really. So that can't be an answer choice. A plus 11 times B. Well, we need to multiply what? 11 to both A and B, not just B. So that's obviously not going to be the case either. And same thing with C. Yeah, we need to multiply what? 11 to both A and B in order to make it divisible by 11. So finally, let's take a look at D. 2 times A plus 2 times B. Well, if we take a look at it, then what is it? It has both the common factor of 2. Therefore, this is going to be equals 2 times A plus B. Is this an integer multiple of A plus B? Yes, it satisfies the condition. Therefore, we may conclude that this particular answer choice, 2 times A plus 2 times B, is divisible by 11. Hence, answer is D. And of course, last but not least, if we take a look at the A minus B over 11, the final answer choice is, well, does it have is A minus B instead of A plus B? Well, does it have anything to do with the integer multiple of A plus B? Sure, for very specific values of A plus B, A and B, that could be, but it's not. Therefore, this is not a specific answer choices. All right. So what we want to do is, while these could be divisible by 11 for some specific values of A and B, we want something that will always be divisible by 11 no matter what we set to be A and B are, as long as A plus B is divisible by 11. And D is the only one that satisfies that condition. Henceforth, D is the answer.